Present CERN. I'm okay. Do you hear me now well? Yeah. Is it okay? Okay, nice, thank you. So, once again. So, I'm Donat Csikos. I work at CERN at the Accelerated Controls Group. I'm part of a small DevOps team, and part of my job is to do Eclipse plugin development and support.
I'm Jed Anderson. I work on the Secure Delivery Center product at Genutech. I'm the development manager. And in a past life, I was an Eclipse committer. I worked on the debug team. We're here to talk about how CERN was able to use Eclipse to support all of their Java and C++ needs and scale it up to the level that they need with the minimum amount of support staff that they have.
Okay, so for the beginning, let's start with a small introduction about CERN. So what is CERN? Okay, so CERN is the world's largest particle physics research laboratory. Over 10,000 people work here near Geneva on the Swiss-French border. Our biggest experiment is the Large Hadron Collider, which is a 27-kilometer ring around 100 meters underground. Inside the LHC, particles get accelerated into nearly the speed of light and smashed together inside gigantic instruments called particle detectors. This is what you see on the video now. And by analyzing the data coming out from these detectors, physicists are trying to improve our knowledge how our universe works. But why are we talking about this? Normally, you would think that this is a place just for the physicists who are doing their crazy science and it's not interesting for software developers at all. Well, in reality, CERN employs 10 times more engineers and technicians than research physicists. You can see on this pie chart that most of our staff does technical and engineering-related work, and only 3% do actual physics. Why is it like this? Because we have to build big experiments. This is one of our particle detectors called the Atlas. It is as big as a 5-story building and consists of around 7,000 tons of sensors, electronics, all type of equipment. Another engineering achievement with the LHC itself, which consists of 27 kilometers of superconducting magnets, which has to be cooled down to the temperature of 1.9 Kelvin, which is roughly minus 270 Celsius. Well, this is why we say that CERN is the coolest place in the universe. Okay, I work at the Accelerated Controls Group. Our main job is to do software for the beam. And on this picture, you can see our main clients, namely the operators in the main control room. They are the people who actually run the LHC. You would ask, how much software do we need to maintain the beam? Well, the answer is, we need a lot of software. We have a large set of GUI applications running on the consoles inside the control room, but this is just the tip of the iceberg. We have a big 3-tier architecture with the GUIs on top, a huge middleware infrastructure in the middle, and the hardware access layer with embedded system on the bottom. Well, it seems like an easy to understand system, but in reality, we have a really, really complex system. So you can see here a visualization about our middleware infrastructure, which is where every dot is a middleware process, and every connection between this every connection is a network connection between these processes. So overall, we have hundreds of machines, thousands of processes, and millions of lines of code, mainly written in Java, surprisingly, but we also have C++ for the lower levels. So this is the complexity what we have to maintain. And this is where Eclipse comes into picture. We use it because it's very good for Java and C++ development, also because most of the technologies come with Eclipse integration. And moreover, if we have to, we can use it as a platform and we can extend it. We all know Eclipse is great. This is why we are here. And this is why Archad, one of the members of the community, and I would like to ask him to tell us more about his CERN experience.
Thanks, Donna. I got the privilege of visiting CERN last year, and it was really awesome to see one of the things that you realize when you go into that control room is that the beam is their master. Everybody spends every moment at work focusing that beam and making sure that it doesn't go down. And the main reason is monetarily. It's very expensive to operate. They run it in about 10-hour cycles where they create the beam, then they collide for a while, and then after a while the beam's integrity fails, and so then they dump the beam. So every hour that they're down, it's $100,000. They like to joke that every day that they're down, that's another retirement home for one of the scientists. Additionally, there's 100,000 parameters that they need, well, more than that, to control the focus of the beam. So we're talking about a really, really large set of parameters that they have to constantly be adjusting. So it's very fragile, and it's also really dangerous. They have a hardware layer that will shut down the beam if anything happens. But the energy is about the energy of a TGV in Switzerland. Now, I don't know if you know, in France they go a lot faster than 150. But in Switzerland, that is the legal limit that they can go. So you have the energy of this train focused in to the eye of a needle. And at the point of collision, they're actually down to a few microns. So we're talking about extreme precision and a lot of energy. So they need to make sure that their code is really good. And they have these really high quality assurance standards, so they brought in all these plugins to monitor their development process. And that's where our product fits in. The Secure Delivery Center allows them to deliver those products to their developers in a consistent way so that they can say, yes, we know you're using PMD, and we know you're using PMD with our settings that guarantees that we're going to have this high level of quality.
Okay. So now we are going to show you a small visualization about how our SVR repository look like, how it changes in 1 week. So here you can see that the white tree is the SVN source tree, and the moving nodes are the developers who are committing into this source tree. So the point is, why we are showing this, is that most probably we have a very distributed environment, which is in fact true, because we have a huge code base, we have around 1 million lines of code, and we have over 1,000 jobs in production, and our teams are working independently, organizing their work in an agile, informal way, which basically means that the coordination is done along dependencies and stable APIs. So the real point is that we have very special conditions, and to support these conditions, we have to give people some special tools. This is one example. Actually, this is an in-house plugin I wrote last year. This is for discovering dependencies. Basically, with this, developers can select a specific part of their API, and they can query who exactly is using this API amongst the 1,000 jars I just mentioned. Another example is this one. This is for the hardware developers. With this, they are easily can integrate their hardware into the control systems. So basically, these are the examples how we extend Eclipse and use it as a platform where no off-the-shelf solution exists.
So another interesting part of developing at CERN and being a developer at CERN is that a lot of your colleagues are going to come and go within 3 months to a couple of years. In fact, a very large portion of their short-term staff members are students who come during the summer. They're rounding out their education. So CERN has a unique situation in that they need these people to be effective immediately. And these are just bright people, but they need to on-ramp really fast. So that's where tooling comes in. You could give them a wiki, they could follow it, but that's going to be a day of them just setting up their work environment. So they needed a tool that would allow these people to be effective immediately. Additionally, they've only got 2 guys, Donut and one other guy, to support these 200 people. And they don't provide support like, hi, I've got a problem, can you help me? Donut says when he gets an email or a phone call, it's get up from the desk and walk to this guy's desk or girl's desk and support them personally. You know, get a personal relationship going with these people and a communication cycle going with these people so that they say, this UML editor just doesn't do the job that I need it to do, things like that.
Yeah. So we really have to support 200 developers, and we have just 2 people to do it. So the only way to do this is to provide one tool stack. Because if we create one consistent environment along with the customizations what we need for our environment, then the developers can work with minimal setup time. They don't have to waste their time by really adjusting small things, and we can still provide excellent support for them. But on the other side, we have to take into account that our developers are really, really inventive. They are constantly finding new tools, they are finding better configurations, and they are somehow expect us that we listen to their feedback and react accordingly. So in order to keep them happy and keep things going, then we really have to be flexible on the standardization process.
So CERN came up with this solution. This was their high-level solution for supporting these people. First, they're going to provide the one tool stack, and they're going to say, you're going to use this tool stack, or you can go off and do it yourself, that's fine, but we're not going to provide this awesome level of support. Then they said, okay, obviously we have to provide the flexibility. Our developers keep coming back to us saying, we need a better tool for this, this configuration for this tool doesn't work, things like that. So they needed a tool to push those updates out to the users and to push the changes that they provide, that flexibility that they provide to the users, because they didn't want to rely on the developers following the wiki and losing time doing that. And then finally, when you push out those changes, you have to be respectful of the configuration that developers have made themselves. So if somebody likes to code on a black background with yellow text, and somebody else wants to code on a white background with black text, you have to allow that. So it's this 4-pronged approach, the intersection of flexibility and supportability, and it's a benevolent dictatorship is what it is. Although, because they say you can do your own thing, it's not quite a benevolent dictatorship, but that's the idea, is that if you're going to get support, you're going to take what they give you.
Okay, so we started to create Eclipse distribution, and when we started, we thought, well, how hard could it be to create our own Eclipse distribution? It seemed really easy. Just find all the plugins what you need, find all the customizations, put it in a zip file and on the website, and problem solved. And in fact, we tried. We spent 6 weeks on this project. And after 6 weeks, we found even more problems than the things which we could solve. We had a lot of problems, but just to give an introduction, the first problem that we faced is that we had to create update sites. And since our developers work behind a firewall, we had to proxy a lot of update sites too. Which raised our biggest concern is that we had to find a consistent set of plugins. Which means that, just to give you an example, if you have 2 plugins with the same dependency, but with a different version number, then you cannot install both of them at the same time, because they cannot fit into one Eclipse distribution. So if you want to create one consistent Eclipse distribution, we had to check all the possible combinations for the plugins, and within our resources, it seemed impossible. Also, we had a problem with support, because if we tried to do initial support for our testing distribution, and every time there was a problem, we had to check what's going on. Are they configured everything? Are they using the latest distribution? Have they updated all the plugins what they have installed? And it was really time-consuming.
So yeah, that's what you see there in the first user scenario. Someone had installed 3.4 and then said, oh, this new plugin doesn't work. Or you'll have these architecture mismatches. This is something that we see in the industry all the time. We have 64-bit machines now. Somebody downloads a 32-bit VM and then says, oh, I've got a 64-bit machine, so I'll install the 64-bit version of Eclipse. Well, that doesn't work, and unless you have seen the error before and have diagnosed it and know what that weird error message means, it can be a hard thing to figure out on your own. Not only is it a hard thing to find the right version of plugins, but they also had problems at CERN finding the right version of command line tools versus plugin tools. So for example, SVN has a different code base entirely for the plugin that they were using versus their command line SVN, and they were getting different behaviors. Also, if you get a new version of Java installed on your desktop, and that is the default Java, then Eclipse will start up and say, oh, you're running Java 6 now, so you can call string is empty. Never mind the fact that when you check that in and run it through your build, you're going to get errors because string is empty was only added in Java 6. We've all seen this dialog on the right of your plugin conflicts, and trying to diagnose that can be complex. That was another problem they ran into. And then finally, update sites do disappear on you. As much as we try to be good about our update sites, keep old versions around, things like that, I think the community could improve how it uses its update sites and how we manage our update sites over time. And that was a problem that they ran into. So this is where the tools start to come into play more. You don't want just Eclipse and just a Java, but you also want the setup for that. You need the workspace configuration for your developers to be truly effective. When they sit down at the desk the first time, you want them to click a button, have it install easily, and have preferences all set up, have the projects imported into the workspace. Maybe you've got some extra binaries on the side, you want those delivered as well. It's looking at the workspace as more than just Eclipse, as a combination of the settings and the projects and everything all together as one. And you want to deliver that in an easy way. You want it to be as easy as going to a wiki, and then you want it to be even easier. For example, they've got some plugin misconfiguration issues that they've been working through, specifically around when plugins don't use the Eclipse Preferences API. It's very easy to have an Eclipse preference file and apply that, but if you've got, for example, CheckStyle or PMD installed, they like to save their preferences in a different place. And so having that be automated was challenging. Also, CERN wrote their own views, and unless you are a long-term worker at CERN, you're not going to know about them. So they wanted a way for their developers to see those views when they first logged in and become acquainted with those views right away. So then you've got it installed, now you have to keep it up to date. And then you really want to enforce these updates. And in fact, that's what they do. They say once a week, we're going to put out a new version, and we're going to say, you must take this. And at first the developers say, I'm too busy, I don't want to take it right now, you're going to mess up my environment. But when you're talking about something as expensive as the particle accelerator, you really need to enforce that. And everybody has a different level of quality assurance that they need to meet. And it just happens that in the CERN case, enforcing that is really important. Also, when a new version of Eclipse rolls out, 4.2 rolls out to 4.3, when is it going to be, in a month or something, you can't say to your users, okay, throw away everything you have and start over. You really need for them to just be able to upgrade in a simple way. And so this dialog you see is the simple, you have updates to apply, it'll apply updates for software, it'll apply updates for workspace preferences or for project changes. And if you want to roll out an Eclipse, like the complete Eclipse, it'll roll that out for you. So you don't have to reinstall Eclipse and then reinstall your plugins on top of it. In CERN's case, they don't really need to roll back, but sometimes people have this problem. And especially when you have code that you have in production and you used one tool stack for it, and then you have a new tool stack for your new up-and-coming code, and you need to be able to switch between those easily. So how do we scale? One way is with staffing, although the matrix of testing, as Donat alluded to, is really, really large. So you could hire a lot of people and try and test all this, but you get to a point where it's just overwhelming and you can't keep hiring people. So you have to use development tools and deployment tools that allow you to push out these changes easy and to test them easily. Packaging everything into one cohesive unit really makes it easier for you to support. You can say, look, did you take the updates? Yes, I took the updates. Okay, then I know you're on this version of this plugin or this version of this binary tool that you can use. Start small and grow. You know, some people, like at CERN, they have one development environment that everyone uses. And over time, you can say, okay, we'll add another one. But it's important to really start out with a small test case and just prove that you can do this support, and then grow into the larger scale implementation. And then finally, and I think this is the most important, is the collaboration that they have with their developers. The fact that they are getting up out of their seats and walking over and saying, hi, how's it going, to their developers, means that there's this communication channel back. SDC allows you to push communication out to them, saying, oh, we have a new version of Eclipse, but you're not getting that channel back, and it's really important that you talk to your developers and say, what are you guys using? That's good. We want to change that because it has these problems. Or you get the feedback from your developer, I really need a better tool for this. And then you can do your job as the tool stack provider to go out and find a better tool.
Okay, so I think we have still time, so 10 minutes. So I will spend, I will show you a few examples what kind of softwares do we develop at CERN. Because as I mentioned, we have over 1,000 jar files that we use in the control systems, and we have a bunch of GUI ones as well. So this one is for logging. The LHC itself produces a lot of logging data. We are talking about terabytes of data. The data about certain parameters like temperature, stuff like this. And with this tool called Timber, people can actually visualize what kind of logging data is in the databases. The second one is called TIM. It stands for Technical Infrastructure Monitoring. These are the applications which run in the control center. And in this, the operators can really monitor and control certain properties of the LHC and the accelerators in general. And the interesting fact about this tool is that the tool itself is just a toolbox, and the actual views are done by the operators and not by the developers. So that's why it's a bit interesting. The third one is called fixed displays. You can, if you go to CERN, and I really recommend to go because it's a fascinating place, even if you are a tourist. If you go there, you can see these applications everywhere on screens in CERN, even in the restaurants. So if you, for instance, if there is a problem, people can see that there is a problem with the accelerator. They can drop their knife and fork and they run back to the control room to fix the issue. The last one, what I'm going to show you, it's called the sequencer. Basically, this is a driver seat for the LHC. This is, to say it easily, it's a workflow engine for the LHC. It has around 1,000 parameters, 1,000 tasks defined inside, and these are the tasks which drive the LHC: how to start up, how to maintain operation, and how to stop. Okay, this software also has an interesting story, which is like this is done by Eclipse technologies partly. It uses SWT and JFace for the UI layer. Okay, so we are at the end. I would like to summarize things. How was it possible to scale up Eclipse for a CERN level? So first, you have to invest into centralized tooling support. One option is to let every developer spend 5% of his time setting up and maintaining his environment. But at an organization like CERN, with 200 developers, it's much more easier to have a centralized team who delivers the tools and the configuration. Second, you have to be a benevolent operator. So we have a message to our developers: you either with us, you use our tools, and you get support, or you are on your own. We provide one consistent tool stack. We provide configuration, and we force people to update once a week. On the other side, we listen to our developers, and we try to be as flexible as possible. And the third and the last thing, use tools over documentation. Yeah. if the configuration and the update is done automatically, then it's much easier to maintain a consistent working environment for everybody. People also still can use documentation from sites like the Eclipse community sites or books, but the best tools are the ones which just work out of the box. And I think that's it. We finished. Yes. So, questions? Yes?
How do you decide when a new release of third-party software or Eclipse or whatever is safe to deliver to your team?
Well, it's entirely up to us. So it's like a dictatorship. We say that, okay, now it's the time. But also we have to be careful because our developers tend to just work, and they don't want to get interrupted. So when we test it internally and we say, okay, it's fine, then we have a first line of defense. Like there are some developers, okay, they are the tester people, and if they experience some problems, they can give us feedback, and then if we find everything all right, then we ship to everybody our updates. Yes?
Do you have any numbers presenting which is better, the dictatorship that you are practicing right now or the anarchy that was in the past? I mean, to show the exact savings that you have gained by your approach.
The saving is the support itself. So normally, originally there was a distribution, and one guy created it, and people started to use it. And as the time passed, we had more and more job with it, because people started to complain, it doesn't work, they cannot update, they cannot use the tools which worked before, but it doesn't work now. And we felt like that we need even more and more people to do it. And at some point we just said, okay, stop, we will create a new environment, people should use it, and we can spare a lot of time for us. Because our team, our small section, we have 8 people, and just 2 people dedicated to this. And at one point we said, okay, it's not possible to continue. Yes?
How do you address the fact that different teams may sometimes need different tools? For example, there's a team who work only with C++, and there's another team which works with Java plus EMF plus GMF. Do you have different tools, or do you provide a complete tool?
Right now, we have one consistent tool stack, but it doesn't mean that we don't have different distributions. So we have different distributions, one for the C++ and one for the Java developers, but they share the configuration. So behind everything is the same, but we have a list that, okay, for the C++ developers we have CDT, and for the Java developers, I don't know, we have a different compilation tool because we have a different stuff. So yes, we have a separation between the distributions.
And I've seen that actually in the industry where you have the need to have that separation. And as we said during the talk, it's best to start with one big one and then start to split things out as you say, okay, this is getting too big, we need to split things up a little bit more.
Anybody else? Okay, I think that's it. So thank you very much for your attention.